Lesson 3.5 is slope of tangent lines. We have learned that a tangent line is different from a secant line. A secant line is a line that touches a graph at two spots versus a tangent line just touches at that one spot and should match the curved slope there. So the last two lessons of just those interactive sliding the points close together were supposed to help you see that as our points slide closer together, the slope gets more accurate there instead of being such an average rate of change. And so we have what's called the difference quotient. It's a formula that allows us to find the slope at a specific point. So right now this is the slope of the secant line. So that would be finding the slope of this line right here. We have a point at x, y, right? X, f of x is x, y. What happens is then we go this distance of h away, and we don't really have a number for that, but we just call it h. So it's so far away from x. So this point now is called x plus h. So say this was 2, this was 3 away, 2 plus 3 would make this at 5. And then that point has a y value of f of x plus h. Okay? And so that's where those come from. So this is like your y2, basically. And then as we take this point and we slide it closer and closer and closer to here, my h value is getting smaller and smaller and smaller. I'm closing up the gap, if you will. I'm getting it to where it's not so far away, and now it's almost right on top of each other. And those 2 points then create a tangent line where it's supposed to just graze right there, giving me a much more accurate slope at that curved part of the graph. That's the basics of it. And so where this formula comes from is having my y2 minus y1. So my f of x plus h, that second height, minus the first height, over, and then this comes from having x plus h minus x, because this was my x2 and this was my x1. Well, x minus x cancels. Sorry, that's plus. X plus h, right there, minus x. But my x's cancel, and that's why you only see an h in the denominator. So if you can remember this formula, you'll remember every time how to set it up. So then we don't want just the secant line. Now we actually want to find the slope of the tangent line, which is actually a limit. So we're trying to get that h distance to get closer and closer to 0. We're closing in the gap here and getting the points really close together. So to find the slope of a tangent line, it's actually doing the limit as h gets closer and closer to 0 of f of x plus h minus f of x all over h. So let's try a couple with the math. Here's our function, f of x. Find the slope of the tangent line. So we're going to want to do the limit as h goes to 0. I like to just write it first. F of x plus h minus f of x all over h. Our x value is -7. So now what I'm going to do is put -7 in when I see x. So it'll be the limit as h goes to 0 of f of -7 plus h minus f of -7 all over h. Then what I'm doing is when I see f of something, that means that that gets plugged in for x. So I'm going to take my function here, and when I get to x, I'm going to replace it with -7 plus h. So I'm going to not write the limit right now, but I'm going to do 12 times -7 plus h plus 11. I have to write the whole thing. Now this minus f of -7, I would rather just go on and know what that is. F of -7 is just plugging in 12 times -7 plus 11. Right, it's just finding a y value when x is -7. So 12 times -7 plus 11 is -73. So f of -7 is -73. So then what I know I'm doing is minus that value, which turns into a plus 73, all over h. It gets easier, don't worry. So then all you're doing is simplifying. I'm going to distribute my 12 times -7, and that should get -84 12 times h is 12h. And then I'm going to go ahead and add 11 plus 73, which you should do in your head is 11 plus 73, which is 84. All over h. So you have the negative 84 plus 84 cancels. And then you have your 12h over h, and your h's cancel. So it equals 12. That is the slope of this function when x is negative 7. That's what we found. All right, let's try another one. That was linear. Now we're going to do quadratic because I have an x squared. So I would start again by saying, okay, your limit as h goes to 0 of f of x plus h minus f of x. This is your y2 minus y1 all over your x2 minus x1, which simplifies to h. Your x value is 8, so that's going to get plugged in for x. Okay, I would go ahead and find f of 8. So 8 just gets plugged in here and here. It would look like negative 4 times 8 squared plus 10 times 8 minus 6. So y is negative 182. Holy moly. That just helps me know exactly what value gets plugged in here. Okay, but here I can't do that. I have to simplify since I have an h. So 8 plus h is going to get plugged in everywhere I see an x. I'm going to go all the way down here. So I've got negative 4 times 8 plus h squared plus 10 times 8 plus h minus 6. You got to write the whole function, and then it's minus f of 8, which we already figured out was a negative 182, so that'll turn into a positive. All over h. So there's some work to be done. We have to FOIL this because remember, having something squared, a binomial squared, means that you're taking it times itself. So I can do that in my head. I've got negative 4 times 8 squared would be 64. You're taking in 8h times an 8h. That's how I just multiply these two and then double it, which would get a 16h and then h squared. Distribute the 10. It's 80 plus 10h. You could go ahead and combine your like terms if you want. Negative 6 plus 182. Oh my goodness. Negative 6 plus 182 is 176. All over h. Then we need to distribute the negative 4. So negative 4 times 64 is negative 256. Negative 4 times 16 is negative 64h. And then negative 4h squared. I'm going to go ahead and put my 80 and my 176 together. That's 256 plus 10h. Stuff should always cancel in these. So if you don't get something to cancel, that means you did something wrong. So my 256's cancel. I can then actually put my h's together too, can't I? So I'm going to have negative 4h squared. And then negative 64 plus 10 would be negative 54. H all over h. You can go ahead and cancel an h from both terms. If it helps you, you could factor out an h from the top. So that would be h minus, or times negative 4h minus 54. So see, I'm taking h from each term. That's my GCF over h, and then they cancel like that. Or you could have said, okay, h squared divided by h, that's a negative 4h. Negative 54h divided by h, that's negative 54. So let me bring that actually up here. So remember, this is still limit. We have to get h to go to 0 because we're trying to close in that distance where our points are really close together. So if I can direct substitute, then great. So h is 0, negative 4 times 0 is 0, minus 54 gives me negative 54. You will get better at them the more you do, I promise. But what that is saying is that our slope, when x is 8, of this curve function, because actually this is a quadratic, when we have a point on there and we're finding the slope of the tangent line, the slope of that line must be negative 54.